Hi, everybody, and welcome back to the lecture series. And today we're going to talk about start a new chapter. We're going to start chapter 10. Like I mentioned before, the 1324 is a very diverse class, right? Try to cover many topics and try to give you a taste about what is probability, statistic, finance, and the also like in the marketing and the linear programming is touched many topics. So the chapter 10, we're back to the algebra again. So the purpose for the chapter 10 is to try to prepare you if you do plan to take the next level 1325, the business calculus. So this is then the chapter 10 will prepare you to to go to that class. So we're going to focus on the chapter 10 back to the algebra. We're going to talk about the different functions here. So in the chapter 10, we're going to cover 5 very useful functions, and those are the functions you have to know in the, in your 1325 the calculus class. Okay, so we're going to talk about the quadratic, polynomial, rational, exponential, and logarithm. So I think after you know these 5 functions, you should be fine in the 1325 calculus class because they're going to dealing with all those functions here. Okay, so for today's lecture video, and instead of go to directly into the function, we're going to talk a little bit basic about the definition. What is a functions here? Then we're also going to talk about if you give me a functions, then how do I find the function values? Then how do I know the relations you defined is a functions? All right, so that's why we call it the vertical line test. Then we also talk about the domain and the range of a function. Then we're going to talk about the one special one is the even and odd functions here. Okay, so this will be today's lecture video will be able to cover. So now, okay, so now let's take a look at the definitions here, right? So we're going to, today is the first things here we're going to talk about is what is the functions, right? So we're going to talk about the definition of the functions here. Okay, so we said the way we define the function is we said a function is a rule. Okay, letter assigned to each element from one set exactly one element to another set. Okay, so what's that mean? So that means here, right? So like for example, here. So this is my X, this is my Y, right? So I have like a different X values here. For example, well, let me get a little bigger. So this is a little, oh, okay. So that's not good. How do I redo that? Let me see here. Oh, redo, undo. Well, let me see. Can I undo that? Ah, okay, good. Okay, so I don't know why okay, so we better not erase it, and then you're going to release the, we're going to release my typing also. So like this is y1, y2, y3. Okay, so for examples here, right? So we say we have some x value, we have some y value. So function, what is a function? That means you defined a relation or a rule. The key things here, that means here, for each numbers here, right? You need to find exactly the one, exactly the one elements to the other set. That's why here is the keyword, exactly the one elements to the keys to the other side. And when I used to teach, when I taught like those the middle school and the middle school kids, when they first deal with the functions, the way I told them is like I said, the function is like, when you find a girlfriend or boyfriends, right? So like each boy, they find the girls, right? And so like in here, so if you have something like in here, so this is X and this is Y, right? So if you have some values here, if you have some values here, right? So if you define the relations like this one, so if by this one and this one and this one and this one, then we say this is not the functions here. So this is not the functions. Why? Because that's why I told them, I said, hey, for one boy, right, you cannot date the two girls at the same time. That will give you a lot of headache, right? So this is not a functions. And when the kids was young, they are always like very excited about the boyfriend, girlfriend. So you told them that, they remember. So like here's one boy, you cannot date two girls. So, because that's what exactly is like they said, you need to have one element, right? So this is not functions here. Okay, so now like in here, if we have another ones here, this is X and Y's, right? So this is my another one. This is X and Y here. So if I have the different X values here, I have a different Y values here. And then if you do like this, so if you define the relation, you say, hey, here, all right? Okay, so in here, these two, they both go into this Y values here. So the way I explained to those kids, I said, hey, the two boys, they can like the same girl. That's okay. They can like, the same girl can be, like the 3 or 4 boys can like the same girls, right? So that's two boys, they can like the same girl. So this is a function. So this is a function. Okay, so it just tell you here, that's why the functions definition is whatever in here you cannot go to the two people. So, so if like you cannot have one x as two y, so that is not a functions here, right? But if you have two x, they go to the same y. So like if you have two boys, they like the same girl, so that is okay. Okay, so this is a functions here, and so then we also defined, we say, hey, this part, whenever my X here, I call this is a domain, right? And this one, I call this is a range here. So the domains, what is the domains here? Domain is all the possible. So it's all the possible values of the independent variable. In the functions. Okay, and now what is the ranges here? Now in ranges here is the resulting set, right? So the key part here is the resulting set of the possible values of dependent variable. Okay, so that's what we said at the functions here. So the definition of the functions, right? So the first thing here we cover here, definition of the function. That means it has to be 1x to 1y. Okay, they don't have to be the different y. So like this example, the green examples here, both these two x's can go to the same y. That's okay. They don't have to be the same different y. But one x cannot go to two y's, right? That's what we defined as functions here. So exactly one element. And then also, so that's why we said this is a function, right? So we said this is a function. So we can define that this is a function f of x equal to y. Okay, so and this one's here, we said this one is not a function here, right? So this one is not a function because 1x go to the 2y, so we don't know what is the function values here. So that's the first thing we say is the functions here, right? Now let's take a look. How do I find the value of these functions here? Okay, so let's take a look here. So okay, so here, that's the examples here. That's find the value. What I mean, find the value. Okay, so let's take a look at the examples here. So if I define the functions, so here, if I define the function f of x is equal to the x squared plus 2x minus 1. So what I mean, the f of 1. This is one of the, this is what I called, this is one of the what? Function values, right? So what's that mean? Look here, right? So this is x, right? So this is 1. That means for every value of x, you replace with 1. So that's why the function value will be everything for the x you replace with 1. So this is 1 to the square plus 2 times 1 minus 1. So what is the answer? This answer is 2 here, right? So that's what we mean, the function values here, right? Okay, so then the next things here, let's take a look at the other ones here. This one is a little bit more complicated functions here, but still it's the same. So if this one's here, I define the f of x is equal to, so this is the 2x plus 1, x minus 4, and if x is not equal to 4, and here is equal to 7 if x equal to 4, so here, okay? So let's read the way we read this function. This is what we call the piecewise function. Okay, so that means depend on what the value you give me, I go to find the different pieces of this function values here. So for example, if I said f of 4, that means you replace x with 4. So where is x equal to 4? X equal to 4 is related to this piece, right? So that's why I know the value of here, this will be 7 here. All right, then now let's take a look at f of equal to negative 1. What is f equal to negative 1? That means f equal to negative 1. So I go to for this piece is when x is not equal to 4. So when x equal to negative 1, so I will use that piece. So remember like we did in the previous one, that means everything in the x you need to replace with negative 1s, right? So that's why I have a -1 minus 4 to the -1 plus 1 here, okay? And then now this is -5, and this is -1, so give me 1/5, okay? Let's we said find the values of of the x here. So okay, so now we have to complete this one's here, right? So that you just go to C, you just replace the value of x with whatever the value you want. So what is the vertical line test, right? Okay, let's take a look at the vertical line test. Okay, let's see here. Okay, so the vertical line test. Okay, so remember we say functions, right? So that means 1x can not have 2y's. Well, like not necessary true. 1x cannot have more than 1y's here. So let's take a look here, right? So let's take a look at some example. What is the vertical test means here? So if for these functions here, let's see for this graph here, this is x and y. So if I have some function like this, if this is a function, we say yes. Why? Because if you put a vertical line, that means you find the vertical lines here. Doesn't matter where you put the vertical lines, right? So how many y it touched? Only one y, right? So we said, yes, this is a function passing the, so this is a functions, right? So this is a functions. So passing the what? Vertical line. Okay, so now let's take a look at another ones here. Okay, so how about if I turn around this curves here, right? So how about if I turn around so that this ones here, I do like this. Okay, so this is my x, this is my y. Now let's do another vertical line test. See here. Okay, so if you do a vertical line test, then you will find out for every x, how many times I'm going to find one y values. I'm going to find the two y values here. So like for the function, we know you cannot, right? So you cannot have one x have more than one value. So this is not a function, right? Okay, so let's do one more. So how about let's take a look if I have a circle here. Okay, so if you have a circle, then let's see, is this going to pass the vertical line test? If you have a vertical line here, vertical line here, vertical line here, then as you see, for each vertical line, the x, how many y you touch here? Wow, you touch two y's here, right? So I know this is a functions. No, not a functions here, right? Okay, so this is what we mean the vertical line test. So from the graphing point, you will see whether, if it's touched more than once, right? So then this is not the functions here. So let's go back to our previous one. So we did finish the vertical line test. So the next ones here we're going to talk about is domain and the range, okay? domain is a little bit easier than range, and so we're not going to put too much emphasis on ranges here. And okay, let's start. So what is the domains, right? Like from the page 1, we say is the value of x here. So, the domain, in general is the value of x, right? So in general is a whole real number, except they have some restrictions here. Okay, so this is quite important. So I'm going to write here for you, domain restriction. So when you look for functions here, like I say, in general, you will say, oh, the domain of this function is a real number, except, certain things. Okay, so here, first restrictions here. If your functions okay, so if your function is a fraction, okay, so that means it's a fraction, then the restrictions here is your denominator cannot be 0, right? So we know of fractions, if your denominator is 0, it's not defined. So, like when you see a function, if it's a denominator, it's, if you have a denominator, you need to make sure you get rid of the point, the denominator equal to 0. Then you can get your domains here. Okay, so how about if your functions, second one's here, has square roots. So if your function have square roots here, all right, so then inside the square roots, has to be greater than or equal to 0. That's it, right? So that's it. And that's when at the end of this chapter, when we talk about the logarithm, we're going to add one more restriction. But right now, when we look for the domains here, right? So we are only looking for these ones, right? So first one's here, denominator. If you have a denominator, cannot be equal to 0. If you have the square roots, right? So if you have the square roots, it has to be greater than or equal to 0 here. Okay, then the problem will become pretty easy here. So let's take a look at some example, then you will see what I mean here, right? So I'm finding the domains, right? Okay, so I find the domains here, the A's here, the f of x is equal to 2x plus 3. Do I have any fractions? No. Do I have any square roots? No. So the domain is the all real number. Or you can write it like from the negative infinity to the positive infinity, right? It's all real number. Okay, and that's how I think the MyMathLab will want you to do that. Okay, so the second one is here. Let's take a look. F of x. If my f of x is equal to the 3x plus 9. Oh, you see, okay, I have a denominator. So that's what is my restrictions here. So I say, oh, if I have a denominator, my denominator cannot be 0. So I will say, what is the value of the denominator be 0? So this is 3x plus 9 equal to 0. So I minus 9 both sides. So I got a 3x equal to negative 9. So divided by 3, divided by 3. So the x equal to -3. That means I need to what? I need to exclude, right? So I need to exclude this number. Okay, so like we talk about in general, my domain is from the negative infinity to the positive infinity. But now for the x equal to -3, this is -3, I cannot have -3, right? Because I need to exclude it, because the -3 make my denominator equal to 0. So what is my domains here? My domain will just be negative infinity to -3 union -3 to the positive infinities, right? So remember, this is a parenthesis because I cannot include that. Okay, so if you remember these two rules, then it will be pretty easy. Okay, now let's take a look at part C here. The part C, if I have of f of x is equal to the 4x minus 5. Then you say, oh boy, I have square roots here, right? So I have a square roots here. So everything about the square roots, then I have to be greater than or equal to 0. So what is the things inside the square roots? Because here, right, everything inside the square roots has to be greater than or equal to 0. So that means you need to have 4x minus 6 greater than or equal to 0. Right? And then you plus 6 both sides. So you have a 4x greater than 6. You divide it by 4, you divide it by 4. So it's x is greater than 6 over 4. So 6 over 4 is 3 halves, right? So it's x is greater than 3 halves. So that means here, right? So this is 3 halves here. So it's equal, so it's greater than equal to 3 halves. So this will be my domain. So you can write your domain will be what? So you put a close parentheses here. This is a 3 half to the positive infinities here, right? Or, like sometime, okay, so that's kind of like just you have a function. It's very easy. You just look at, and then you can see what is the values, right? So sometime, they will give you a graph here, and then want you to identify the domain and the ranges here, right? So in here, so for example, this is a 6, this is a -2. If I have a function, something like this, okay, so I start from, okay, so this is my functions here, right? So I start from here. I just, for examples here, okay, so I will go, my function goes something like this. Right, so you see the arrows, right? So here this start with like a circles here. So by looking for this graph here, so you know your domains here, right? So the domains is everything less than 4. So it's 4. So will be negative infinity to the 4, right? Then you will see your ranges here, right? So your ranges here by looking the graph, the topmost one is 6, but then this arrow can go down to the infinity. So the ranges here will be from where to where? From the negative infinity to 6, right? So 6 probably you will reach it. It will touch the 6, so then you can put the close parentheses there. Okay, so that's why, from the graph, and then you might ask, what is the range for all this? And like I say, it's not quite easy. So we're not going to talk about in this time. But if they give you a graph, you should be able to see the range is the y's, right? So the range is the y value. So we're going to talk a little bit more about the range in the later sections here. Okay, so now the next one here is quite important. We're going to talk about what is, right? So what is the even functions? Even versus odd functions. Okay, so I'm going to show you the graphic, what is a graphically means, right? So we're going to show you the algebraically and the graphically, right? So the first thing is, let's take a look. What's the I mean is the even functions here, right? Okay, so a even function will be a function something like this. Okay, so if I have a, maybe let me use a different color, maybe it's better. Okay, good. Okay, so like this one, okay, so like in here. Okay, so if this is what we call the f of x, then this is what? Even function. Why I say this is even? Because look here, it is what? It is symmetric to the y-axis. That means while outside is sundering. That means if you folded it, this will be the same, right? So the y-axis is like kind of like mirrors here, right? Okay, so now let's take a look at what is the other functions here. So the other functions, let's take a look here. So if like these functions here. So this is the f of x function. And then this f of functions here, so this ones here is what? What are they symmetric to? So this ones here is symmetric, right, to the origin. It's kind of like you bend this curve to the origin, then these two curves will be the same. Just like if you folded this even numbers here, it will fold it according to the y-axis. So this is symmetric to the y-axis, right? So by using the graph, you can see it. But sometimes, we cannot graph it. It's kind of sometimes difficult to graph the graph. So how do I algebraically? I can see that. Instead of say, hey, this is, this is a symmetric to the y-axis, or this is a symmetric to the origins here, right? Okay, so algebraically, for the even functions here, the way you see that is if f of x is equal to f of negative x. Okay, so for the other functions here, right? So if, so what is algebraically? That means f of negative x is equal to the negative f of x. Okay, so these are the two very, very important rule. You need to remember how to define the even and other functions here. Okay, let me try to give you some examples here. So it's pretty easy, right? So let's say here. So if I want to see, I give you a simple one. If f of x equal to 3x, is this is even or odd? Okay, so when we talk about even or odd, we always start with, you put the negative x into your function. We always start with, you put we always start with, you put the negative x into your function, then see what happens. Okay, so remember that's the function value, right? That means everything in the x you need to replace with negative x. Okay, so this one will give you what? 3 negative x, right? Now the 3 negative, you can see here, this is 3x. Oh, kind of like a magic, right? So what happens here? Oh, this one, what is this one? Hey, this one is f of x. So I prove the f of negative x equal to negative f of x. So what type of the functions here I have? I have odd. Okay, now let's take a look at the other one. Let's see here. if I have like a f of x equal to x squared plus 5. Let's see if this is the odd or even, right? Remember I said we always start with negative x. Okay, so let's start with negative x again. Remember, right? We always start with negative x. Okay, so you plug in the negative x into where? Into your original function x. Oh, I'm sorry here. Okay, so where you plug that into? You plug into whatever the x is here, right? Okay, so now let's take a look here. The x you replace with negative x, right? So this is negative x, the whole thing squared plus 5, right? So negative sign, you square that. What happens here? Negative x, you square it, negative, negative. So be the x squared plus 5. Oops. Well, what is negative x plus 5? Hey, exactly equal to the f of x. So I know the f of negative x equal to the f of x. So what type of functions here? This is even functions, right? Okay, let's take a look again. Okay, so let's do like the 3x. So let's say 3x plus 5, right? Let's take a look. What is these functions here? So always start with what? Negative x. So remember that? So let's always start with negative x. Then substitute negative x to whatever your x is, right? That's always the step. Always start with negative x. And now here you will have the 3 negative x plus 5. And so take the next, so this is negative 3x plus 5. You say, okay, let me factor the negative out, see what happened here. So this is negative 3x. When you factor out, this is 5. Oh, then you look at it, you say, oh, 3x minus 5, but here's 3x plus 5. So it's not equal to f of x. So the f of negative x is not equal to negative of x. So what happens here? So what is even or odd? Neither, right? So this function is neither because I cannot match. So I know, so from here, I know f of negative x is not equal to negative f of x. Also, f of the negative x is not equal to f of x. That's why it's neither, okay? So that's what is the section 10.1 we will talk about is the basic definition about functions. So we talk about the domain, we talk about the even and odd, and also talk about how to find the value and the vertical line test. See here. Okay, so after this, and then the next ones here, we're going to talk about the specific function, like quadratic functions and the log, exponential. Those are the very, very important functions you're going to use, okay, in the next level of the class. Okay, so, and nice to talk to you again, and I hope you all did very well on the midterm exam number 3. And I really miss you guys, but I don't know whether we'll be able to see each other for the final or not. So, okay, so looking forward for the next lecture videos here, right? So you guys have a good time and be safe. Okay, bye.